Coverage you can count on continues. This is News Channel 15's First News Weekend.
Well, even though it's hot outside, that doesn't mean you can't have fun inside, especially at Science Central.
Always. The organization offers various learning activities and experiments for visitors of all ages. And today, Martin Fisher of Science Central is here for another exciting edition of Science Sunday. Good morning, Martin.
Good morning. Yeah.
Always love having you in.
Fantastic. Today we're going to talk about something called Bernoulli's Principle. All right, you're a meteorologist, so you know all about famous French scientist named Daniel Bernoulli. He was alive in the 1700s. He was a mathematician and a physicist, and he studied pressure. He noted that when a fluid, and by the way, a fluid is both a liquid and a gas, when a fluid would move, it would decrease the pressure. So I can show that very easily with a really expensive tool.
Piece of
machinery, a piece of paper. What I'm going to do is I'm going to blow air across the top. So moving fluid, the pressure up here is going to be less than the pressure underneath. Greater pressure down here, it's going to push the paper up. Or does that push up the paper? The paper's going to move up. There we go. Easy to see. So now let's take it a step further with our leaf blower.
A little more power.
I've just got one of those laying around.
So with the leaf blower, I'm going to place a golf ball on top. The force of the air moving up is going to push it up. Gravity is going to pull it down. But the fluid, the air, is going to be moving around all sides, going up equally. So the pressure is going to be identical, equal pressure on all sides, and it will stay suspended in this column of air. I'm even going to try to turn it sideways a little bit, and you'll be able to see that even sideways, the air pressure is equal on all sides. The ball will stay suspended. Now it's going to get loud. You won't be able to hear me talk here. Even when I turned it sideways, it stayed suspended. Now, there's an easy way to try this at home as well. You don't need to worry about a leaf blower and a golf ball. Instead, all you need is a hairdryer. Rob, do you want to try this one?
Sure.
Oh,
fantastic. Okay, so if you try this at home, you can either use a styrofoam ball or a ping pong ball. Either one will work. So we'll start with the ping pong ball. Okay. You'll go ahead and let's make sure that it's on first. That always helps. Reset. There we go. Ah, fantastic.
Got it.
So you're going to keep it suspended and then try to turn it sideways just a little bit.
Right towards you.
Yes.
You ready?
I'll be ready to catch it.
All right.
All right. Let's go ahead and turn it on. Hey, fantastic. So you'll notice that the force of air pushes it up. Gravity's pulling it down. But because that air, the fluid, is moving in every direction, it's keeping the air pressure on all sides equal, so it stays suspended. Now let's try it with the styrofoam ball. It might even go a little higher this time, because this ball's a little lighter weight. Well done. And what this is showing, again, is Bernoulli's Principle, which was studied by Daniel Bernoulli in the 1700s. Interestingly enough, he was even doing some of this research with another type of fluid, blood and blood pressure fluid. Yeah.
Now, real quick, too, I wanted to ask a question for the folks at home, too. Does it matter if it's because it's hot air coming out of the hairdryer, or can it be any kind of air? Because obviously
it can be either one. Now, what I did was I went ahead and turned it onto the cool mode just because I didn't want to melt either of you guys.
Appreciate that.
From me to you. From me to you.
But obviously, pressure deals with some temperature differences there too.
Exactly. But for this particular experiment, you wouldn't have to worry about it. You can put it on hot or cold. Now, of course, when we're dealing with temperature, as you know, in a container, let's say you fill a balloon with air, but then the temperature gets warmer inside of that balloon. The molecules get a little more excited. They start to move around faster. They move apart a little bit. The balloon will start to expand. Good way to show that is do the opposite. Get a balloon, fill it with air, put it into your freezer for a couple of minutes. And when you take it out, very quickly look at it because it'll immediately just start to expand a little bit as it gets warmer.
The reaction to it.
Yeah, because of air pressure and that temperature relationship with the molecules.
All right, well, thanks for coming in. Just a reminder for everyone at home, summer vacation's over, but that doesn't mean you close up shop.
You can still come into Science Central.
That's right, just north of downtown under the big smoke stacks. You find it 12 to 5 there, Wednesday through Sunday.